sorry. Wait, this is what I wanted to do. Okay, so given. So here it says Discount Sounds has 260 retail outlets throughout the United States, right? This is basically the saying that is all that they have, right? 260 outlets throughout the United States. That means that that is our population. So I should do white because so N is equal to 260, the capital N. And that is, I'm going to write it here. You don't have to do this part, but just in case until you get used to it. So I will write the population size. Then it says the firm is evaluating a potential location for a new role based in part on the mean annual income, right? So here, what does this tell us right here, right? That we want to estimate the population mean. Okay. Then it says a sample of 36 was taken, so n equals to 36. Because we're not taking one at a time, we're taking a group. This right here tells us that this is a sample and distribution. Okay. And then we says mean income, sample mean income, right? So that means that X bar is equal to 41,100. Then since the population is not believed to be highly skewed, right? Not believed to highly skewed, which means that you can probably approximate a normal distribution. That's what it's telling you. And we're going to talk about sample size later, and we'll know that, because you have a sample size of 36, that is actually, you can use this, and the sample size is enough to do this problem. And it says the population standard deviation. So this right here, right? Population standard deviation is 4,500. So this is the sample mean. This is the sample size, and this is the population mean. Population standard deviation. And it says the confidence coefficient, right? Confidence coefficient is supposed to be 0.95, right? So that's what's given to you. Now, since that's what's given to you, we'll say, what is it that, so what does this imply, okay? So we imply that, that our alpha is equal to 0.05. What else do we know? Okay, so now let's take a peek and let's look at the formula that we would use, okay? So hopefully in the meantime right now you could probably pause and see what you would do. Like, it's better if you actually do the problem and not necessarily watch me do it, okay? So now the formula right here, right? We have that X bar plus or minus Z alpha over 2 times the standard deviation divided by the square root of n, where this right here is the sample mean, right? This right here is the margin of error. So now let's take a look, right? And we say, okay, so now we'll say this is number 2 formula. Number 3, we'll say what's missing. Okay, so we have X bar, right? I'm going to rewrite, that'll be a little redundant, but I'll say that I have that. I have sigma, which is 4,500, and I have n, which is 36. What I am missing is the C alpha over 2, which really corresponds to 0.025, okay? And when we look at this Z, we're going to be looking at the positive Z-scores for now, okay? Positive Z-score. So how do you find that? So there's usually a table. I actually, I think I put this table. So if you look at this, all of you should have, so let me just, like, for example, look at a Lexis folder. So in class notes, you have everything. I think for examples 1, 2, and 3, what I'm doing right now. And for handouts, you have something that says critical values. There's a table right here. It says for confidence level, the critical value is like the alpha over 2, basically. So when we have a 95% confidence value, you'll see that it's 1.96. Okay, that's the critical value that we're looking at. So I'm going to go back to my notes. So I'm going to also say that Z alpha over 2 is the critical value that we're looking at, okay? So we know that it's 1.96, but let's say you don't have a table, because just in case you don't have one for the final exam, you could calculate that using Excel. The way that you would do that is you would type, let me see if it allows me formulas. Okay, let me see if can I do that? Okay, so it's equal to, because we're going from a probability. So basically what we want, draw, wide, come on, I want to draw. Oh, it's because I have this equal sign up here. Okay, so now it should allow me to draw. So because I have this right here, right? So the area of 0.025 is somewhere over here. This is the Z, the critical value that I am looking for. So it's easier to look at the area to the left of it. So if I click on this cell right here, so if I say, so if I say equals to, so I'm going from a probability to a Z-score, so I'm going to say equals the norm dot inverse dot S. So it is norm dot, see right here is 1, 2, 3, 4, the fourth one down. Norm dot, dot S. And it's this one right here. I don't know why it's looking like this, but that's the one we're looking for. And it says what probability that we want to look at. So we say we want 0.025, which is, if you round this to like 3 decimal places, this is equal to negative 1.960. You could also get this, just remember that this Z-score, right, the Z-score, the critical value rate, this is negative, this is positive, because they are mirror images of each other, right? The way that you could get this one over here, that if you wanted to positive, right, you could do all of this area, which actually means that you're looking at an area of 97.5%. So if you do this, so if you do equals norm dot S dot inverse of 0.975. It gives you the same value. So that's what you can find. So they want negative 1.960. So I'm just like trying to see how to change this so it rounds for you. But I'm doing this on my tablet, so you should be able to see this a lot easier on your in your computer, in Excel on your computer. Alrighty, so we found 2 different ways that we could do this. So I'm going to go back to this problem right here. So I have the Z-score is 1.96. So now at this point I have everything that I need. So now my final step is plug everything back in the confidence interval. So I have 41,100 plus Z-score 1.96 times 4,500 divided by the square root of 36. Okay, so this gives me approximately 41,100 plus or minus 1,470. So this right here is my margin of error. And we're going to call this one E. Okay, so to do the interval, what I have to do is I have to do 41,100 minus 1,470 to 41,100 plus 1,470. So my interval is going to be 39,630 to 42,570. So what does this mean? We say that we are 95% confident that the interval contains the population mean. Or in context of this word, of this problem, okay, that will say that the mean annual income, okay, so we'll say, so in context of the interpretation, will be that the mean, let's look at the problem, that the mean annual income of the mean annual income of the stores, the mean annual income is of the stores is, so the mean income, so actually we'll say that we are 95% confident that the mean annual income of the stores is between 39,630 and 42,570. And that's it. So quick recap what we did, right? So every time you do a problem, the first thing you have to label the information, write down what you're given, use letters. Don't write necessarily like in Word because that's not going to help you to find the right formula. We found the formula, then we figured out what was missing. In this case was the critical value for corresponding to a 95% confidence level. You can get the 1.96 from a table, or you can use Excel using the norm.s.env function. And then finally you plug everything in. Well, once you plug everything in, you get your confidence interval, right? So this is your confidence interval. But once you find your confidence interval, what you have to do is, the last step is you actually have to interpret the data. So this is the interpretation of the data. Alrighty, so next we're going to do a problem with the population standard deviation not known, okay?